Let's now talk about binary search tree. Okay, binary search tree in continuation to our binary expression trees. Last meeting we have talked about this one, the binary expression trees, part 1 of the binary search trees. So we have also talked about the theories and definitions of binary search trees. Okay, so let's proceed to tree traversal. So tree traversal, we have 3 walks. Actually, we have 3: in order, pre-order, and post-order. On the in order, so we have walk in a divide and conquer algorithm. It prints all elements in monotonically increasing order. So that's the in order 3 walk. Okay. We have also here a sample pseudocode of a in order 3 walk or an in order algorithm. Okay. Here we have a binary search tree node onto a one-dimensional interval. Okay, as you can see here, so we have an equal binary tree or binary search tree. So if you check, we have an in order type of binary search tree. Because number one reason is that, as you can see in the nodes that are given, so we used to have an in order type, which means we have to traverse from left, visit the root, and traverse from the right. So as sequential, as you can see, as a sequential order. Okay. On the other hand, in the pre-order with 3 walk, we have processes each node before processing its children. So we have also an algorithm of this, or a pseudocode of what we have regarding the pre-order 3 walk. Okay, so normally a pseudocode is an English-like program or programming. Okay, but naturally this is not the actual program that we have. So meaning this is a blueprint of your program. So another one is post-order 3 walk. Post-order corresponds to it processes each node after processing its children. So processes node first before processing each children. Okay, on the post-order. Corresponds to the evaluation of trees with values on level and operators on inner nodes. Okay, we have also this post-node, or post-order 3 walk pseudocode. Okay, continue. On a binary tree traversal, we have here the guidelines on how to follow the binary tree traversal. Although we have 3: in order, pre-order, and post-order. Okay, so on the binary tree traversal, to visit all nodes of the 3 in order, not commonly used as finding, inserting, deleting nodes, useful in some circumstances, and simpler than deleting a nodes. Okay, but normally binary tree traversal is used in order, pre-order, and post-order. On the in order traversal, so we have the node has a left subtree, or if the node has a left subtree, so you have to traverse from the left in pre-order, recursive call. Okay, so once completed, proceed to step 2. So otherwise, proceed to step 3. So meaning, when you encounter a subtree, a left subtree, you have to proceed first to the left subtree. Otherwise, you have to proceed to number 2, which is you have to read the root node. Okay, and on number 3, we have if the node has already subtree, if the node has a right subtree, so which means you have to traverse from the right. Okay, in pre-order recursive call also. Recursive meaning you have to visit it again if there are some more subtrees in the right subtree. Okay, this is the example of a tree, subtree, and also a subtree of D. Okay, so what we have is we have to determine the in-order traversal. In an in-order traversal, we have to get first the left subtree, then followed by the root, then you have to visit the right subtree. So after that, if you evaluate the left subtree of D, for example, then you have to visit the root and go to the right subtree. That's why we have these numbers, or we have these letters, okay? Like A first, then B, because we have to visit the root, then C, then visit the right subtree. Okay, if none of the subtrees are available on the left subtree of D, so you have to proceed to right subtree. Okay, but before you begin proceeding to right subtree, you have to visit the root. That's why we have the letter D here. Then proceed to right subtree. So again, recursive call, so you have to visit the traverse from the left, then visit the root, then traverse from the right. So that's why we have E, F, G here. Okay. What about the preorder traversal? In the preorder traversal, we have read the root node first. Okay. Then, if the node has a left subtree, all you have to do is traverse from the left in preorder recursive call. Once completed, proceed to step 3. Okay, but none if there are still, okay, or if there is none of the subtree on the left. So all you have to do is proceed to number 3. On the number 3, you have, if the node has a right subtree, traverse the right subtree in preorder recursive call. Okay, so an example of this is we have this tree again, okay, this binary tree again. So all you have to do is, if you want to read this using preorder, so which means you have to read all the roots first, okay, because it is a preorder. So you have to read the root nodes first, like we have here D, then followed by B, then followed by A and C, because we have to go to the left and the right after the root, left and right. Then proceed to the right, visit the root, traverse from left, then go to the right. That's why we have these letters, sequence of letters, okay? On the postorder tree traversal, we have this guide. If the node has a left subtree, traverse the left subtree in a preorder recursive call. So once completed, proceed to step number 2. So otherwise, proceed to step 2. Otherwise, if there are, or if there is no subtree on that portion, okay, so you have to proceed to step 2. So you have to visit the right subtree. So traverse the right subtree in preorder recursive call. Once completed, proceed to step number 3, or otherwise proceed to step 3. Read the root node. Okay, so on the postorder traversal, so which means you have to visit the left subtree, then right subtree, then you have to proceed to the root node. Okay, so as an example, we have here the same binary tree that we have last time, okay, but this time you have the postorder traversal. In the postorder traversal, so all you have to do is traverse from the left first, then the right, then visit the root, okay. Then again, you have to skip the root here because you have to visit this one at the last part, okay. So traverse from the left first, okay, letter E, then you have traverse from the right, letter G, then visit the root, okay. So that's why we have this answer. Binary tree traversal sample exercise. So we have given an expression tree, okay. So we'll apply this one to our in-order, preorder, and post-order tree traversal. Okay, on the in-order, we have this sequence. So symbol node, the plus, minus, so we have this one, symbol node, and the tree that we have to evaluate this one by one by node, okay? The in-order sequence here will appear after we evaluate this tree, okay, or this binary tree. So first, in the in-order sequence, so traverse the left subtree, subverse, so you have to find the left subtree of the plus root, okay, so which is this one. But in the in-order, so you have to traverse again, okay, so you have to visit the subtree if there are still subtrees on the left, okay, as we have here, we have still left subtree. So we have here the symbol that we are traversing, okay, then we have to traverse again. Next, we have the asterisk, traverse from the left subtree of the asterisk, okay, so then we have a. A is not the root, this is the node now because there is no left subtree of A. So thus, this time we'll have to read the root node. Node A has no left or right subtree. So that's why we have to read the node. Okay, so completed. So next, proceed to read the root node, which is asterisk, because after you read the left subtree, you have to visit the root, okay, then you have to traverse from the right. So that's why we have traverse right subtree, okay, we have letter B. Okay, so on the B you have to read because there is no left or right subtree of letter B. So that's why we have to read this in this sequence, okay. This portion was already evaluated, okay, read and traverses. Okay, so all you have to do now is go back to the root of the minus symbol, then proceed to the right. Okay, in the in order, so after you read the root node, which is this one, the minus symbol, so go to the right. Okay, on the right side to continue, you have to traverse from the left, okay, from the left. So if you have this left, no, then the letter C has no subtrees or have no subtrees. So all you have to do is go back to the root. Okay, you have to visit the, after visiting the node C, so you have to read the root node, which is the division symbol. Okay, then go or proceed to the right, which means we have to traverse from the right. So that's why we have this letter D. Okay, so then after that, you have to go back, to this node, root node. Okay, so that's why we have here the plus symbol. Okay, then proceed to the right of the plus. The subtrees of the right of the plus is we have division E, F. So which means if there is a subtree, so you have to proceed from the left. Okay, from the left. So you have to read the E. Read the E, then right in sequence, we have E, then read the root nodes, go back to the root, then apply the division, then go back to the left, right rather. So that's why we have the letter F. So which means the tree and its subtrees and the nodes have already visited and completed. So that's why we have this final answer. Okay, so proceed to pre-order. In the pre-order traversal, we have pre-order sequence. Okay, so as you can see, we still have applied the same tree. But this time we will be using pre-order. So which means we have to use the root first, the roots. Okay, then after that, the left and the right subtree. So visit the root, we have plus, visit the root of minus, we have minus, then visit the root of asterisk, this one, then we have the asterisk. Okay, then traverse the left subtree, traverse the left subtree of asterisk, we have A. Okay, then proceed to B. So meaning after you write A, then you proceed to B. Okay, write B. So after that, so go back to the top of the previous node of this node. So which means, or this left subtree, so which means we have the minus. So we have to go back here, or we traversed here from to the right and to the right. So we have this subtree. Okay, so again we will apply the recursive call, which is the traverse from the left. Now after you visit the root, then you traverse from the left, traverse from the right of D. Okay, then after this subtree have completed or is completed, so we have to proceed to the right. Okay, so that's why we have this right. Okay, so now we have to go back to step number 1. Traverse from or visit the root, traverse from left, and traverse from right. So that's why we have this next step. Okay, so visit the root, traverse from left, then traverse from right. Okay, then this is the last node of this tree. Okay, so which means this is the final answer of the pre-order traversal. Okay, what about on the post order? So on the post order, so we still have the same tree, binary tree. So all you have to do is to apply the post order. In the post order, so we have those steps, like you have to first traverse from the left, traverse from the right, then visit the root. Okay, so all we have to do here is we have to read the the plus symbol. So after the plus, we have to traverse from the left. If there are still more subtrees, traverse again from the left. Okay, if there are no more subtrees like this one, this last subtree, so all you have to do is visit the nodes of the left and the right subtree. Left subtree, okay, we have A. Right subtree, so this is the right node of this right subtree. So we have letter B. Then after that, we have to go back to the root, okay? Because on the post order, so left first, then right, then go back to the root, okay? So in the post order, we have the asterisk, okay? Then after that, you have to traverse from the right again, then apply the recursive call, traverse from the left, then traverse from right, okay? Traverse from left, traverse from right. Okay, so that's why we have this number. Then you have the division, then followed by the minus. Because there is no subtrees on the minus, we have already evaluated this one and also this one, so which means we have to evaluate the root. Okay, the root. Okay, then you have to go back to the right subtree of the plus tree. Okay, we have here right subtree. On the right subtree, proceed to the left. We have to traverse from the left. Okay, on the left subtree, we have no nodes after letter E, so which means we have to traverse from the to the right. Okay, traverse to the right. Okay, so after that, you have to write the answer in sequence. Then go back to the root node, okay, which is the division. So we have here the division. So read again the root node at the top, again at the top, because this is the last part, the last node that we have to read, okay. So what happened is we have visited or traverses the left subtree first, then the right, then visit the root, then traverse from the right. If there are still subtrees, so you have to visit the left subtree, right subtree, then again visit the root, go back to the roots, then proceed to the right, then first visit the left subtree, right subtree, visit the root, and the root. That's why we have this final answer. Okay, more exercises. Okay, so if you think you can now follow, you can proceed to using this binary search tree, binary tree. Okay, you can apply, you can use this tree to use the pre-order, in order, and the post-order type of the tree. Okay, so much for the tree traversal. So I hope you enjoy with our topic for today. So thank you. So please do like and subscribe for more videos to come. Thank you.